Dear student, this video is about magnetic flux. We will define magnetic flux. We will explain the dimensions and formula of magnetic flux. In physics, the word flux is represented by Greek letter phi. So if I define a flux in general, flux is flow of something. It is basically flow of something through a surface in given amount of time. So this means that flow of something through a surface is basically the rate of the flow of things through a surface is basically it is a flux. Higher is the rate of the flow of something through a surface, higher will be the flux, and lesser is the rate of flow of something, lesser will be flux. Consider that we have a surface S. Suppose that this is some kind of surface S. And we have air molecules near this surface S. Suppose that these are the air molecules. And these molecule passes through the surface S. So the number of air molecule passes through the surface S is basically in a given amount of time is known as air flux. So this air flux will depend on the velocity of the air molecules, velocity vector, area of the surface, and as well as the number of air molecules. So this means that if the velocity of air molecule is more, it is more, then this means that the air flux will be F air, phi air will be more. Similarly, if the area or the surface area is more, then this means that the flux, air flux or number of air molecule passes to the surface will be more. And furthermore, as you know that the flux is basically it is a rate of flow of something through a surface. So this means that flux also depend on the time. So more is the amount of time, there will be a more amount of things passes through the surface. Lesser is the time, lesser will be flux. So flux depend on these three main variable. It's depend on velocity, area, and time, and it's also depend on the number of some things. If we have greater things passing through the surface, greater will be flux. Magnetic flux is represented by Greek letter phi b, and it is defined as number of magnetic field lines passing perpendicular to the surface. So now Dear student, basically the magnetic flux will be defined, or it is based on the number of the magnetic field of line which are passing through the passing perpendicular to the surface. So greater will be the number of magnetic field of line, there will be a greater amount of magnetic flux. As you know that, dear student, in a magnet there are basically magnet consists of two poles. One pole of magnet is known as north pole and other pole of a magnet is known as south pole. The magnetic field of lines are generated from north pole and they go toward the south pole like this. Student, please keep in mind that number of magnetic field of lines, number of magnetic field of line, magnetic lines gives us information about the strength, about the strength of magnet. If a magnet has a greater magnetic field of lines, greater amount of lines or magnetic field of lines, then the magnetic strength of such magnet will be more. And a magnet with lesser amount of magnetic field of line, the strength of magnet will be less. So, dear student, the strength of magnet is basically associated with the magnetic field of a line. The closer are the magnetic field of line and greater is the amount of magnetic field of line, basically tell us that the strength of magnetic field is magnet is more. And if the magnetic field are far from each other and the amount of magnetic field of line are also less, then such types of magnets are known as weaker magnets. So, in case of magnetic flux, the magnetic field of lines which are generated by north pole of magnet are they basically pass through the surface. And if the greater amount of magnetic field line are passed to the surface, then greater will be magnetic flux in that surface. So now consider we have a magnet. This is a north pole of a magnet, or this is a north pole of a magnet, and this is a schematic representation of a south pole of a magnet. So the magnetic field of line, basically they are generated from north pole and they go toward the south pole. Suppose that we have a certain surface, which is basically placed inside the north and south pole of a magnet. And the surface of this surface S is perpendicular to the magnetic field of line. The number of field of line passing through this surface, magnetic field of line passing through the surface, will be magnetic flux. Now, There are four magnetic field of lines, as we can easily see. So the field of lines are basically magnetic field of lines are associated with the magnetic field. If the amount of magnetic field of line increases, suppose from 4 it goes to 10, then this means that the magnetic flux phi b from 4 will increase to 10. So this means that magnetic flux phi b depend or it is directly proportional to the number of magnetic field of line. Greater is the number of magnetic field of line, greater will be magnetic flux. Similarly, dear student, the area, magnetic flux also depend on area. And as you know that area vector from the surface, area is a vector quantity, and from the surface as it is always perpendicular. So this means that magnetic field of line in a surface which is perpendicular, this means that that a surface which is perpendicular to the magnetic field of line, the area vector of such surface is parallel. Area vector is parallel to the magnetic field of lines in such surfaces. And when the area vector area vector A is parallel to the magnetic field line, then this means that maximum amount of flux, magnetic flux, will be produced. Area vector is parallel to magnetic field lines, then magnetic flux will be maximum R. So this means that magnetic flux is directly proportional or depend on the area. If the area is parallel, then the maximum amount of magnetic field of line will pass through. If we combine both these, magnetic flux directly proportional to magnetic field of line and magnetic flux directly proportional to area, so then we can get that magnetic flux B is equal to B dot A. Dear student, the term B dot A is a scalar product. Which means that a magnetic flux is a scalar quantity. So then the formula for magnetic flux will become, since it is a scalar product of magnetic field and area, so the formula for magnetic flux will be BA cos of theta or BA cosine theta. So then the formula of magnetic flux become BA into cos of theta. So now let's come toward the angle theta cos of theta. Why angle cos of theta is used in this formula? For this, we need to understand the schematic diagram as we previously presented. Suppose we have a magnet with a north and south pole. This is a magnet with a north and south poles, and we have a surface S. Suppose this is a surface S. Let me rewrite again. Suppose that we have a surface S which is present inside the magnet poles, and the magnetic field of lines, they go from north pole toward the south. Since you know that sine theta sine theta is equal to perpendicular our hypotenuse, whereas cosine theta, cos of theta is base over hypotenuse. So basically, for a surface which is perpendicular to the magnetic field of line, in case of cosine theta, the magnetic field of line which will basically crosses the surface from inside. They will basically magnetic field line will pass through the surface of the will pass through the surface, and that is the reason of the cos theta is basically used with a magnetic field B. In case of if the sine theta is used, sine theta is basically it is a perpendicular hypotenuse. So this means that magnetic field of line need to pass not to pass through inside the surface but from the edges, and which is basically in such situation there will be a no flux. However, if the angle between the area vector A, which is perpendicular surface, and magnetic field B is basically it is a cosine, then the maximum amount of magnetic field of line will basically pass it through the surface. And please keep in mind, dear student, this vector B or magnetic field of lines are not always perpendicular, not always parallel, not always parallel to the surface, to the area vector A. They are basically interact or pass through the area pass through the surface with a different angle theta. So the beta will be associated with angle theta, and it will be B will be magnetic field B will be associated with angle theta, and it will be B cos theta. So magnetic flux B phi B will be basically it will be area into area, and then it will be a B cos of theta. The angle which is basically the angle which is created by the, suppose these are the magnetic field of, this is area, this is area, let me write it again. Suppose that this is area vector. So magnetic field of lines basically pass through an area with a different angle. It could be with this angle, it could be with angle like this, and so on. So basically theta will be an angle between magnetic field of line and area vector. So the magnetic flux phi b will be depend on magnetic field of lines, and the area which is usually parallel, are the angle of area of angle between the magnetic field of line and the area. So magnetic flux phi b will be BA into cos of theta. So now student, keep these 2 points in your mind. Magnetic flux phi b depend will depend on magnetic field of lines. Greater are the magnetic field of line, greater will be magnetic flux. Or greater is the flow of line through a surface, greater will be magnetic flux. Similarly, magnetic flux depend on area vector or area through which a magnetic field of lines are passed. So if the area of this surface S, suppose if the area of the surface S is increased, or suppose the area of the surface S is decreased, like this area is decreased, then there is less amount of field of lines 1 and 2, whereas the area S, which was bigger, and there were next more amount of magnetic field of line, like this was 1, this was second magnetic field of line, this was third magnetic field of line, and this was fourth magnetic field of line. This means that area of the surface also also basically caused increase in the magnetic flux. So more is the surface area, and more will be basically number of magnetic field of line passing through it. Another question key point to notice is the angle between magnetic field lines and area vector A. So now student, if the angle between area vector and magnetic field B is 0, then in such situation magnetic flux phi B, as you know that it is B into A cos of theta, so the angle is 0, so angle cos of theta 0 is equal to 1, then this means that the flux will be equal to magnetic flux will be equal to B into A. So in such situation magnetic flux will be maximum when the area vector is basically area vector A is parallel to magnetic field. In case if the angle between area vector and magnetic field of line become 90 degree. In such situation, the magnetic flux, we can write the equation again, magnetic flux phi B is basically BA into cos of theta. The angle is 90, so we will write BA into cos of 90, and you know that cos of 90 is equal to 0. So the magnetic flux in this case will be equal to 0. So this means that the direction of area basically through which uh, a magnetic field of lines will basically indicate the strength of magnetic flux, and the number of amount of lines passing through a specific angle to the surface area will basically also indicate the strength of magnetic flux. So now student, let us make a schematic diagram. Suppose we have magnetic poles. One is north pole and other pole is basically it is a south pole. And as you know that magnetic field of lines are basically moved from north pole, they come out from north pole and they go toward the south pole. And again we are considering the surface area S, which we have previously drawn like this. This is a surface S, and suppose if this surface S become parallel to the magnetic field of line, angle of surface S become parallel to magnetic field of line to B. In this situation, the area vector A become perpendicular. Since you know that area vector is always perpendicular to the surface, area angle will A vector will become perpendicular to the magnetic field. So in such situation, the angle between area vector and magnetic field will be 90. So this means that flux through this area will be 0. In case if the surface is basically if the surface S is basically it is perpendicular to the magnetic field of line, in this case area A vector will be parallel and angle between A and B, angle between this A and magnetic field of line will be 0. This will mean that the magnetic flux will be basically the flux, magnetic flux, as you know that angle between B and A is 0. So magnetic flux will be B into A because cos of 0 is equal to 1. So this means that magnetic flux also depend on the orientation of surface through which magnetic field of lines are passing. Now dear student, let us discuss the unit of magnetic flux. Since you know that magnetic flux phi B is equal to B into A cos of theta, B is magnetic field. So the unit of magnetic field is basically it is a Tesla, and the unit of area is meter square. So the unit of magnetic flux phi B will be equal to Tesla meter square. So this is basically SI unit of the magnetic flux. The unit of magnetic flux is also called Weber. So this is all about the magnetic flux. In a simple word, if I explain, magnetic flux is basically it is a number of the magnetic field of line passing perpendicular to the surface area, or passing perpendicular to the surface. So the magnetic flux is basically it is a scalar quantity. It is a dot product of magnetic field of line and area. So magnetic flux is basically it is phi B is equal to BA in cos of theta. The unit of magnetic flux is Tesla meter square. It is the SI unit, whereas it may be represented by a word by a term Weber. So this is all about the magnetic flux. Thank you dear students for watching this lecture.